Welcome back to the channel, ladies and gents. Kev from KRT Electrical Services, and you currently join me in my pantry in my year and a half old house. And the reason we're in this pantry and you're joining me today is because we're going to swap out this lovely Wylex consumer unit. And as you can see, it was only put in less than 2 years ago. And the reason we're swapping out, if I'm going to be blunt, the builder or the electrical contractor who worked on behalf of the builder cheaped out. Let me show you why. So here we are. Wylex. Nothing against Wylex to start off with. Very, very good brand. Make very, very good switch gear, other accessories, etc. But the electrical contractor who installed this cheaped out, and in 2021 decided to put a split load board in with no SPD. So yes. Now there are various different things in the regulations which some will agree with, some don't, and the regulations are sometimes down to interpretation. And my interpretation is that split load boards shouldn't be put in anymore, shouldn't be installed. They're outdated, and they're not, and they don't meet the regulations. But I'll show you why. So let's go out there to the big brown book and have a look, and let me explain my reasoning. So here we are, the big brown book, 18th edition. So if we go to page 156 and section 531.3.2, it's all about RCDs, residual current devices, and this is the section which I'm most interested in. So 531.3.2, unwanted tripping. So residual current protected devices shall be selected and erected such as to limit the risk of unwanted tripping. The following should be considered: subdivision of circuits with individual associated RCDs. RCDs shall be selected and circuits subdivided in a way in which earth leakage current likely to occur during normal operation of a connected load will not cause unwanted tripping. 2. The use of RCBOs for individual final circuits in residential premises. And then number 3, in order to avoid unwanted tripping by protective conductor currents and or earth leakage currents, the accumulative of such currents downstream of the RCD shall not be more than 30% of the rated residual operating current. So what that's saying, in a normal residential property, like in this Wylex board, these two RCDs here, which are rated at 80 amps, but the tripping value is 30 milliamps, as you can see, it should be no more than 30% of that, which if you divide that by 10 and then times it by 3, equals 9 milliamps. So I'm going to show you a little experiment using this little clamp meter as to why I think this shouldn't have been installed and doesn't meet those regulations. So here we go, I've taken the cover off, and it's not a bad installation really, it's not too untidy. Notice I'm not going anywhere near this fuse board with my pointy finger because it's not tested to 1000 volts and insulated, but I'm just pointing at stuff from a distance. So we've got the main tails coming in, which is an SWA, which is not terminated in the wall there, but it is earth at the other end, and then we've got our two RCDs. So what I'm going to do is put my clamp meter onto this RCD because it's a bit difficult to get it on that one, but I'm going to put it on here and see what earth leakage we've got on this side of the installation. All we've got on in this property is the boiler when it kicks in, but that's not on, and then we've just got normal stuff like a fridge, basically a couple of fridges. We've got no lights on, we've got no other devices plugged into sockets or anything like that, so we've got very little on, so no ovens, nothing. So we'll see what the earth leakage is at this point. So we'll turn that on to 200 milliamps, and then what we'll do is we'll clamp that. Try and do this one-handed. Around the live and neutral of that RCD, and as you can see straight away it's fluctuating ever so slightly, but we've got 5 milliamps of earth leakage already. So 5 milliamps of earth leakage with absolutely nothing on in this property isn't a lot, but when we start turning, for example, so on this side we've got smoke detectors, downstairs lights, 2 cookers and a socket circuit. So B32, we've got 2 20s, a 6 and a 6. So as soon as we started turning some downstairs lights on, for example, let's go and turn some downstairs lights on. We'll turn these ones on because they're all LED. And then we'll turn those ones on as well. We'll see what it goes up to. So it's gone up a little bit higher, 5.4. So then we've got 2 cookers on there and we've got a socket circuit as well. So already it's gone up a little bit, not a great deal, but we're only, what, less than 4 milliamps now away from that 30 or 30% of that 9 milliamps. So if we start turning ovens on, I suspect it's going to go even higher. So let's turn the oven on. There we go. And we'll put the microwave on as well. So that's kicked in, the oven's on. Now we've gone up to 33.5 milliamps across that one RCD. God knows why that's not tripping, but it's not. As you can see, 33.5 milliamps. So we're just monitoring it and it keeps on fluctuating. I mean 36, that should be tripping out now. And then it comes down to 20 odd. It really should be tripping, but it's not. So anyway, that would appear that that RCD is probably not working very well, which is a bit worrying actually, because this is my house and why is that not tripping? But the point I was proving, there we go, 23.6. The point I was trying to prove is that just by having 5 circuits on an accumulative RCD rated at 30 milliamps far exceeds that 9% or 30% that it says in the regulations. So that is why we're going to strip it out, because I don't want nuisance tripping. It hasn't got surge protection, which I've been fitting for the last 3 years. And to be honest, it's just a case of the electrician has proper cheaped out. This is new build estate. They whack these in, charge maximum money, or want to make as much money as possible. And that is why they put these boards in, because they're cheap. So yeah, you can see. There we go. Right, let's get on with it. So as demonstrated there, that, not the brand, nothing wrong with the brand, but that board, its configuration, is a load of rubbish. So what we are going to be putting in is this Luden Palazzoli main switch RCBO SPD board, loads of our SPDs there, or sorry, RCBOs. We're going to be putting that in that place and future-proofing this installation as the original electrical contractor should have done, but didn't because he's a cheap. Yeah, so, right, let's close the big book. We're going to go and isolate, and then we're going to take that off the wall, sorry, and get on with changing it over. There's a nice bit of slack, as you can see, so it should turn out to be a nice installation, and we'll try and make it as nice as possible. So, yeah, let's go get on with it. So here we are at the main cupboard, and I've just turned the switched fuse connection unit off and taken the fuse out, but you can see the standard of the installation that the original Spark did. Pretty rubbish. That's a clamp for a lamppost, isn't it? Dogs. So now we've isolated the installation, I'm just going to prove dead using my Martindale proving unit and my Fluke T150 volt detector. So we'll test that first. It's good, 230. Then we're going to go from there to there, nothing. There to there, nothing. And then there to there, nothing. So retest that again. now we're all golden. We're isolated, we've got no power here at all, so we're safe to start dismantling this board. Right, so what I've done is disconnect or unscrewed all the terminal screws, all the conductors are loose, and I've taken these out, and what I'm going to do is number these which correspond with these on this old board, and then I'll know what circuit's what compared to this one, so when I put them away on the new board I'll still know what they are. So I'm yet to number them, but I just wanted to show you like the way some of these cables have been terminated, for example. And I'm not one for pointing out people's bad work, because you know, it's I just don't really want to do it. I don't want to moan about other people's work, but these little 1mm cables, they're not, you know, they're not doubled over. The neutral main tower, you can see, and this isn't live anymore, you can see it's scored all the way down where they've used the Stanley to sort of take the sheathing off the SWA. It's just a bit, not much care been taken with it, but that is the nature of new builds, unfortunately. It's price them high, or sorry, price them low, whack them in, get them done, you know, etc. And then you end up with a finish like this. Half of these terminals weren't even that tight, to be perfectly honest with you, but yeah, so that's where we are. We're gonna get this numbered up and then finally get this thing off the board. Get out, because we don't want you anymore. You're dead to me. The split load board is dead to me. Yes. Bye bye. So what we're installing in exchange for this Wylex split load board is this Luden Palazzoli board. So if we have a quick look at it, nice packaging, nice solid packaging, and then comes in a nice protective film like that. So it's got a nice oval front cover, main switch, enough room for all our circuits, and then pre-wired and built-in SPD, which in my opinion is what the builder should have put in this installation in the first place. So this is what we got going in the place of this split load board. So yeah, I'm excited to get this in. So we've got it all stripped out, we've got our main tails there, we've got our earth there, which they've wrapped tape around it, they've wrapped a bit of tape around it because they've completely scored the neutral there, but I'm going to heat shrink those. Obviously the SWA is loose in the wall, but it is earth the other end, but as you see, really badly. So I will put a new switched fuse unit the other end, terminating in an SWA gland as it should be. And then what we'll do is we'll straighten all these circuits out. I've numbered them all, and then sort of decide what knockouts I'm going to do on the board and then bring them in. So we've got a timber here, which I'll use these existing holes, but I think our new board is a little bit narrower, so we're probably not going to come over this far, but I'll put you on the side. You can watch me straighten these cables out, and then we'll start to offer the board up. So yeah. So these Luden Palazzoli board, there's a few things I quite like about these, nice features. Firstly, their screws on the cover are all captive with those little washers. So that's a really nice feature, so you aren't fiddling around for these screws and stuff like that. So I really like that. The boards are absolutely solid. They work, you know, they're absolutely solid. They're manufactured to a really, really high standard. The buzz bars don't twist, but also their packet you get inside, you get a very, very comprehensive technical specification sheet and installation instructions, along with a few other bits. The plastic blanks aren't so good, and I'll use metal ones myself, because I don't believe you can get modular blanks at the moment for these. I may be wrong. But yeah, they're just very well made, very sturdy, plenty of knockouts, 32s, 25s, 20s, obviously for towels around the sides, big towels one there, and then plenty of knockouts at the bottom as well. So all the screws are obviously all done up, so they're not loosened off, which is good, because sometimes in transit, obviously screws rattle loose if they're sort of not sort of tensioned up really. So I quite like that as a feature. Some people don't, but I do. And then yeah, they're reasonable value. I actually get a decent deal from my local CEF for these boards. So yeah, and the same with the RCBOs really. They're all very, very good quality. Let me get one out. So yeah, they're all very good quality. Your neutral lead is very long. It's got a nice, it's been nicely crimped at the end, so you get a nice solid connection in the neutral bar. And yeah, these aren't the miniature ones, so these are normal ones, but to be honest, I prefer the normal ones. So yeah, and obviously they've got Ludent warranty, as you can see on there. So all in all, a very, very good product that I'm very happy to install. So yeah, let's get on with it. Guys and girls, little update. So I've got the consumer unit mounted, got the towels through. We've heat shrink them, but they're actually far, far too long. So probably going to need to trim these down, reheat shrink them and all that jazz. So a bit of a waste of time there, but yeah, we're all level. Stabiler obviously, yeah, all level. We're all mounted solidly, got some washers on there. Yeah, so we're all golden really. So yeah, I'm going to mess around with these first, because I want that SWA just to be there really, and then shorten these down. Should never have to joint these, because the consumer unit, if it's ever going to be relocated, then it's a big job anyway. So yeah, we could probably shorten those down, and then start putting stuff away, building the board, putting the RCBOs in, etc, etc. So yeah, there we go. So we've got the towels in. As you can see, there's a big void there, but what I'm going to do is fire seal that, because this is just a stud wall. So should we get any loose connections in here and arcing and fire and smoke, that can just go straight up that passage. I know some people don't like people sealing the back of boards just in case they're trying to get other circuits in and it's a pain, but I think it's a good idea. I don't think there's any regs saying you have to do it, but I think it's a good idea, especially in a property. Well, it's got a timber frame inside basically with just studded partitions, so which this has in this wall. So I think it's a good idea. But now we've got all our RCBOs in, so we're going to start populating. First of all, we've got a 40 amp MCB, and we've got an MCB because that's a SWA cable that goes outside, so it's got mechanical protection, doesn't need RCD protection. And then we're going to put a separate board out in the garage with their own RCBOs for those local final circuits out there. So we're just going to mirror this what was already here. I've got my circuits labelled up, so I'll put my RCBOs in according to this. So then, you know, we've got a bit more room, because as you can see the old board was wider anyway. But yeah, so then we'll populate our board, tidy all the neutral fly leads away, and then we'll start terminating these cables into here. This video is more about why I'm installing this, not the actual installation, but I am showing some of the installations because I appreciate there's loads of consumer unit installation videos out there and everyone does it pretty much the same. To various different neatnesses, if that's a word, neatnesses. But yeah, this is more about why I'm installing this and taking a 1.5-year old board out. Basically, in my opinion, because it's not compliant. So yeah, I'm going to get on with this and I'll report back to you shortly. So yeah, I tell you what, for those of you who haven't installed a Ludent Palazzoli board before, I urge you to go and do it. And I'll tell you why. One, because they're a quality product and they're made really well. Two, their RCBOs are better than any other RCBO I've ever installed. So I take particular care in my boards. I like them to be neat and stuff like that. These neutral fly leads, plenty long enough, but they're a lot more chunkier than the likes of fuse box that I've installed before. They're nicely finished off with these metal crimps at the top, so you don't have to crimp them like sometimes the fuse box ones you have to. And the cables are that much thicker that they just dress nicely down behind, and then they tuck like that and they stay in place. I know it's only an aesthetic thing, but aesthetics are important to me as well as something being functional and safe. And these are just better than anything I've ever used. So yeah, if you haven't tried one, go and try a Ludum Palazzoni board. Absolutely brilliant. Lovely. So now I've done that, I've got all my RCBOs in position. Obviously I've put them in rated order, 40 down to 6. A lot of people bang on about, oh, you shouldn't have a 40 or a 32 rated RCBO or MCB at this end of this buzz bar because it pulls more current. Rah, rah, rah. Rubbish. And the heat dissipation and all that sort of stuff. Absolutely rubbish. Three phase board maybe, single phase, you don't have to worry about it, in my opinion. And again, that's my opinion, and what I've just explained is someone else's opinion. So there's differences of opinion. I don't know. But all I know is I've installed boards, with 32 amp breakers up this end before. Touch wood, never had a problem. Maybe that's because I talk stuff up properly, etc, etc. Or maybe I'm just lucky, but I've never had a problem. So I've done it in this order just to keep it nice and neat, but you don't necessarily need to. So, but as I say, this is not an installation video on how I install a fuse board. I'm basically showing you me installing a fuse board, but basically the main reason as to why I'm doing it, and that's because that piece of junk out there is not compliant, in my opinion. So yeah, let's get on with start putting these boys away, make it as neat as possible. And then I'm not going to show you any testing or anything today because that'll be a whole new video. But I've got my tester here ready in this box, or this box here, as you saw a bit earlier. But yeah, this is purely about regs, how I think split load boards are not compliant. So yeah. Right, guys and girls, welcome back. Apologies, but I've skipped on quite a lot. So the board's all fully terminated, as you can see. I had to jiggle around some RCBOs. So these two 32s were up here, but the circuits were short. I had to already extend a couple of these, which I didn't really want to do, but I've had to. So yeah, I had to jiggle around, but I just needed to crack on really. So as you can see, we're all terminated. Relatively neat. I've done neater, but I've done a lot worse. It's my own fuse board. It's as neat as I could get it, with the cables, with the entry points there come through. Ideally you come up behind the buzz bar, cut out 20mm holes, grommet them and stuff like that on a new installation, but it doesn't make any difference. It's neat enough, I can identify everything, etc, etc. So yeah, as I say, this wasn't an installation video and showing you how I install a fuse board. This was more about I am taking a 1.5 year split load board out and then putting in something which should have been put in the first place. RCBOs, so we don't exceed that 30% tripping rate, which is 30 milliamps, and also surge protection. I've been putting in surge protection for the last 3 years. Why did they not do it? Well, the reason they didn't do it is because they cheaped out. So yeah, this is a Beltway house. Obviously the electrical contractor specifies what they're going to put in and the building company agrees to it. So that is what it is. That is new builds. That's the new build game. Do it as cheap as possible. So yeah. So I've upgraded this now. Got to energise it and then do some live testing, but I'm not going to bore you with that. And then I will be back in the future, do a video on the garage, because I'm going to get a new board out there, because now that's on an MCB. You will notice the little fuse box blanks, but I'm going to blank them out because Ludum won't like that. So we'll yeah, that's on an MCB because that's SWA, so it's got mechanical protection, so it doesn't need RCBO protection. So yeah, we're going to put a new RCBO board out in the garage, but that'll be another video. And then also, I'm going to renew that switched fuse spur out there, because you've seen the SWA with the lamppost clamp around it, which is dog rough. So yeah, that'll be another video as well. But for this one, you know, this is the board. The reason I upgraded it, I've already been through, so I'm not going to bore you with it again. And yeah, that is it really. So if in future you have a board upgrade and someone tries to sell you a split load board, I would question it and say, well no, I want an RCBO board with surge protection, because I've been installing these for like 4 years now, maybe longer, and this is, you know, this future-proofs the installation rather than having tripping issues, etc, and not actually meeting regs. So yeah, here we go. So that's that. Voila, there we go. Another episode done, dusted. Hope you enjoyed it. Please like, subscribe if you like what I put out. If you don't, then don't. It's up to you. And we'll see you on the next one. So yeah, bye for now. Goodbye.